Hello friends, this video real number part 6 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched real number part 1 to part 5. Let's understand fundamental theorem of arithmetic. Fundamental theorem of arithmetic says that any composite number can be written as product of two prime numbers. For example, we have 4 as composite number. I can write 4 as nothing but 2 into 2, both are prime. I have 9 as composite number. I can say this is nothing but 3 into 3. I have 18 as composite number. I can say this is nothing but 3 into 3 into 2. Correct? Similarly, let's suppose if I have 21 as a prime number, a composite number, I can write this as nothing but 7 into 3. Both are prime. Correct? I have 33 as a composite number. I can say that 33 is nothing but 11 into 3. Similarly, let's suppose I have 55 as the composite number. I can say this is nothing but 11 into 5. So what I am seeing here is any composite number can be written as product of primes. That is the fundamental theorem. Let's take some example. The question says, consider number 4 to the power n, where n is a natural number. Check whether there is any value of 4 to the power n that ends with 0 digit. That means it is saying that is there any number for n of this form x0 that ends with a 0? That is the question. Now we know that for any number to end with 0, that number should be multiple of 10. If that number is multiple of 10, 5 and 2 should be factor of that number. Correct? Because I am talking, let's suppose I am taking 50. If 50 is multiple of 10, 50 should have 5 and 2 factor. If 40 is a multiple of 10, or let's suppose 30 is a multiple of 10, 30 should have 5 and 2 factor. For example, if I factorize this becomes 3 into 5 into 2. Why? Because 30 is nothing but 3 into 10. So when you are taking 10, 10 is nothing but 5 into 2. So if any number ends with 0, that means 10 is the factor of that number. If 10 is the factor of that number, 5 and 2 is also factor of that number. Correct? So let's suppose if we assume that 4 to the power n is having 0 has, let's suppose, n digit is equal to 0, then 4 to the power n should be equal to k into some 5, that is 5 into some constant. That means 5 should be the factor of 4 to the power n. Correct? That is, if you find the prime factors of 4 to the power n, that should have 5. So let's find the prime factor of 4 to the power n. 4 to the power n is nothing but 2 into 2 to the power n. That is 2 into 2 into 2 into 2 into 2, 2n times. So if you see, these are all prime factors, but it doesn't have 5. So we have seen that 4 to the power n doesn't have 5. 5 is not there. Since 5 is not there, I can say that it doesn't end with 0 for sure. Correct the logic? The logic is, if the number has to end with 0, 10 has to be the factor of the number. If the number has 10 as the factor, 5 and 2 also has to be the factor of the number. Now we have found that 4 to the power n is not having 5 as the factor. So we prove that 4 to the power n is not having 0 at the end. Let's take one more example. Here we have to find the LCM and HCF of 96 and 405 by prime factorization method. Here we are not using the Euclid lemma, we'll use the prime factorization method. So what we'll do, we'll factorize this. 96 will factorize. This becomes 2 to the power, let's factorize this. So 96 will divide by 2. This becomes 48. Correct? Now 48 also will divide by 2. This becomes 24. 24 again we can divide by 2. This becomes 12. 12 also we can divide by 2. This becomes 6. 6 will divide by 2. This becomes 3. And 3 will divide by 3. That becomes 1. Correct? Then we can say that 1, 2, 3, 4, 5. They are 5 times 2. That is 2, 1, 3, 4, 5 times 2 into 3. This is the factorization of 96. What we have done? We have just divided by 2, 3, 2, 3, 4. That's how we do. You keep on dividing the number with the prime numbers 2, 3, 4, 5, 6, those numbers, and then you get the factorization, prime factorization. Similarly, let's try to find the prime factorization of 404. So here if you see 404 also divisible by 2, so we'll divide 404 by So this becomes 202, correct? Now 202 also we can divide by 2. So this becomes 101 actually. Now 101 you know is a prime number itself. So we'll divide by 101. You have to keep dividing by the smallest prime number. So example 404, for 404 the smallest prime number with which it is divisible is 2. Similarly for 202 the smallest prime number with which it is divisible is 2. But for 101 the smallest prime number with which it is divisible is 101 itself, because that itself is a prime number. So we'll take 101. So we can write 404 as nothing but 2 into 2 into 101. Correct? Let's rewrite this. 96 is nothing but 2 to the power 5 into 3, and 404 is nothing but 2 to the power 2 into 101. Now once we have done this, to find the HCF what we'll do, we'll take the highest common factor. For example, for 2's power the highest is 5. See, here it is 5, here it is 2, the highest is 5. So we'll take HCF is nothing but, sorry, for HCF we'll take the lowest. So for 2 to the power 5 and 2 to the power 2, the highest common is 2 to the power 2 here, because 2 to the power 2 will divide this guy and 2 to the power 2 will divide this guy, because when you say 2 to the power 2 divides by 2 to the power 2, that is 1 in this case. And when you say 2 to the power 5 divided by 2 to the power 2, that is also 2 to the power 3. 2 to the power 2 divides both this, right? That is 2 to the power 2. 3 to the power 0 and 2 to the power 1. The highest common is 1 only, so we ignore this, and we ignore 101 also, because 101 is also not common, correct? So we'll say the HCF of this is 2 to the power 2, that is 4. That is the answer, correct? To find LCM, what we'll do, it's other way around approach. Here we'll take the factor which is maximum. For example, for 2's power, the maximum is 2 to the power 5. See, in this case, we 2 to the power 2, the minimum power. Here we'll take the maximum power. The maximum power is 2 to the power 5. Into, for 3 also the maximum power is 3 to the power 1, because here it is 3 to the power 0, that is 1. And for this also we'll take the maximum power, that is 101. So what we'll get is, we'll solve this, we'll get 2 to the power 8 is nothing but 2 to the power 5 into 3 is nothing but, this value is 96. This value is 96 into 101. This comes out to be 9696. And that is our answer to find the LCM. Correct? What we have done? See, first we have factorized this. To find the HCF, we took the powers which are minimum. For example, 2 to the power 2 was the minimum power that is common. We took that. And none other thing is common. So that is the answer. For LCM, we took the highest power. For 2 to the power 2 and 2 to the power 5, the highest power 2 to the power 5. So we took 2 to the power 5. 3 to the power 1 and 3 to the power 0, the highest is 3 to the power 1. We took this. 101 to the power 1 and 101 to the power 0, because this is 101 to the power 0 is 1. So we took this. Also, if you want to find LCM, there is one more method actually. That is nothing but, you divide both the number and multiply both the number, that is 96 into 404, and you divide by HCF. If you multiply both number and divide by HCF, that is true only if you have two numbers. In case of three numbers, this formula doesn't work. So we have two numbers and you multiply by HCF. That comes out to be 96 into 101. By HCF is nothing but 4. Right? By 404. So this is 101. 96 into 101 is nothing 96. And that is the answer. Correct? HCF is 4, LCM is 9696. To find LCM, there are two methods. One is you can take the highest powers and get the LCM, or if you already know the HCF and this is only for two numbers, you can find the product of the number and divide by HCF to get the LCM. Let me repeat once again. To find LCM, first step is find the factors, prime factors. Once you have the prime factors, and then you take the least common factors, right? For example, in this case HCF, the common factor, highest common factor actually. So highest common factor was 2 to the power 2 here, so we took that is. For LCM, we take the least common multiples. Here the least common multiple is 2 to the power 5, 3 and 101. So we found that and we want the product to get LCM. Take one more example. Here also we have to find the LCM and HCF of 6, 72 and 102 using prime factorization. The first step we'll find the factor. So for 6 we know we can write 6 as nothing but 3 into 2. For 72 let's find. 72 is divisible by 2. Yes. So we'll divide by 2. So we get 36. Is 36 divisible by 2? Yes. So we'll divide 36 by 2, we'll get 18. Is 18 divisible by 2? Yes. So we'll divide by 2, we'll get 9. Is 9 divisible by 2? No. By 3? Yes. So 3 by 9, we'll divide by 9 divided by 3, that is 3. Again we got 3. Is 3 divisible by 2? No. 3 by 3? Yes. Well, 3 by 3, that is 1. So we have got this factor. So we can write 72 as nothing but 72 as 2 into 2 into 2, 3 times 2 into 3 into 3. This is 72 actually. 72 is equal to, cross this, let me write this here, 72 is equal to. Similarly for 120, let's find the factor. This is 120. 120 you know it's divisible by 2, so we'll divide by 2. This becomes 60. Cancel. 60 also I know we divide by 2, so we'll divide, we get 30. 30 also we know is divisible by 2 actually, so we'll divide, we'll get 15. Now 15 is divisible by 2, no. By 3, yes, we'll divide by 3, we'll get 5. Now for 5, divide by 3, no. By 2, no. By 5, yes, so we'll divide by 5. So the factor we got for 120 is nothing but 2 into 2 into 2 into 3 into 5, correct? Or we can write this as nothing but 2 cube into 3 square, and this is nothing but 2 cube into 3 into 5, and this is nothing but 2 into 3 into 5 to the power 0. 5 to the power 0 is nothing but 1, but I am trying to make things consistent, so I am multiplying 5 to the power 0 here. Now first thing is we have to find the highest common factor. For highest common factor we have to find the factor which is common, which is highest. So in the power of 2 we see 2 to the power 1 is common, and that is the highest factor. So we'll say 2 to the power 1 into, in case of 3 also we'll see 3 to the power 1 is common, that is highest, because 3 to the power 2 is not here, 3 to the power 1 is common, so we'll take 3. And for 5 we know 5 to the power 0 is common, so we'll take 5 to the power 0 is 1. So SC will come out to be 3 into 2, that is 6. Similarly for LCM we'll take the least common multiple. So here the common multiple is 2 to the power 3, the maximum power, right? For 3 the maximum power is 3 to the power 2, and for 5 the maximum power is 5 to the power 1 into 5. So that is the answer. This becomes 8 into 9 into 5, that is 360. So our LCM is 360 and SCF is 6. That is our answer. What we have done, we have just find the prime factorization of 6, 72 and 120, and then for SCF we found the highest common factor. We found 2 and 3 are the highest common factor. We multiplied 3 and 2 to get 1. For LCM we found the least common multiple. We found 2 to the power 3 and 3 to the power 2 and 5 are the least common multiple. We multiplied it to get 360 as an answer. Now, thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.